We've got there's a current model of our terminal complex with the parking garage and ped bridge going across it. But 5 years ago, we've had a room full of drawings and all the CAD drawings and different files. Like every project would have its own file, and with staffing issues with Transport Canada and then transferred to an airport authority, we didn't have an amalgamated even a CAD drawing, let alone a full modeled BIM Revit model. So and because of this, the product that we gave from as-built out to the construction industry and the designers was what we got back from the last guys. So there was inherent errors with some of the information we passed on to new designers, and what we would get out of it would be a good package. But when the contractors came on site to build, they would start the demolition process and start to open up walls, and the steel was a different size, different elevation, dimensions were wrong, mechanical systems were completely demolished previously, and on goes the story, so that our change orders, we're up to 30% on some projects, mostly in the mechanical and structural field. Architectural finishes, you can see, touch. That stuff was pretty good. I love the painting contractor. He was the cheapest guy and last on site. But all of the hard, expensive work always cost more money because of found conditions and clash detection issues, even with the design clash with itself, and because of the domino effect of old buildings built in the 60s and under construction ever since. We needed to do something differently. So we started off on the process innocently. About 5 years ago, we were doing a terminal expansion for new baggage systems. So the baggage systems were pushed out on the south and north because of new security requirements from Transport Canada, then down through CATSA. So the international community that builds baggage system does it in 3D design. They actually design the whole system in 3D and have all the bolts numbered, and they can do takeoffs right off the model. So during the construction, we were using this model, and then we're fitting it into the building and making sure by doing checks without 3D, without scanning, to make sure it would fit, so that when it came on a boat, it fit the first time, subject to just a few small issues. And it was vastly successful, and we already had Maximo, so the data files were all inside this model. So we did a data dump into Maximo, and our facilities maintenance guys, they were happy because they had all the replacement parts all listed out and documented in advance. So that was a few years ago. So at the same time, I'll use some small projects as examples. There was some old sanitary lines in the center of the building, and much like a residential complex, a subdivision where you add a subdivision on, but the original sewer pipes were no good. Well, we had stores built, and they were tapping into the same sanitary system, which were undersized, clogged with grease, etc. So we had to replace it all, but we didn't know what was in there accurately. So we used SDMM and M&R engineering to reverse engineer what we had. So we scanned through the ceiling. We went out from the farthest tentacle of the system down to where it left the building, scanned the whole thing, and then we had Dan McDonald. He reversed engineered what we needed with some expansion on it. They already had scanned some things. They actually, put the Z direction in a lot of the walls. So that we had, a basic structure. Level of development was low, but it was based on the structural grid, and it had the building. So, ta-da, we have a model. So the concept was we would try slowly by designing all our new projects in using Revit, 3D design, and enriching the model one project at a time with a goal of sometime in the future having our fully developed terminal building. We could have tried to scan the whole thing and draw the whole thing and model it, but that would have cost a lot of money, and with what net benefit? At the end of the day, we want facility management, want to save money in construction projects and schedules and budgets. So this was our way forward. So I'll go into a few projects, and then I'll go into the project we're currently in right now, where we're trying going to the next step. So this after the success of that sanitary pipeline, we had a requirement from WestJet because of their expanded operations in eastern Canada for a maintenance facility. So we had a little pocket of the building that still had some footprint left. So we built out this area. So Stantec got the contract. We didn't specify level development. We wanted basically clash detection, so we wouldn't get any change orders. We pretty much got a 250 LOD for this. So they did the whole thing in 3D design, 2% change orders from design conflicts. The WestJet wanted some stuff, so there was more than 2% change orders, but from design conflict, 2%. And the areas where we had those was, the first area was tying into existing structure, and another one was because they didn't model the existing foundations, the new foundation had to be on piles, so we had to go down below grade. So this is a little $3 million project, but 2% change orders. If it hadn't been for WestJet requests, on schedule. So nice little pilot project and a big win. So we wanted to keep on going with this. Another project that we're currently in the middle of right now is a security infrastructure upgrades. So this project, anti-ramming bollards in front because the world's getting more dangerous all the time and recently coming to Canada. So this project also include blast-resistant glazing and access control to enhance some of the cameras that we have and to put some, basically lock down the basement and any LAN rooms, mechanical rooms, anywhere where someone could tamper in and interrupt business operations. This is the goal of this project. So what we did is that model we already had, Stantec pretty much stripped the front of it off and then showed us all of our security bollards. And then we zoomed in on making sure it worked, the fine details. And this really was important, not just technically. And you've previously seen some of the stripped down detail of what you can do with the different disciplines. But this also helped with management approval, also get the architecture right on where things were. You see a little, these are rated bollards with, foundations that go down 4 feet, and there's steel and concrete that actually stops the vehicle. So we're looking at, on the corners, a higher strength resistance, so there's a concrete structure that also goes down. So that was one of the things we decided, yeah, that's ugly, we don't want that. So it was good for that tool. So we went up with something on the previous, if we zoomed in, we got these big concrete pucks that have no purpose except to mimic a short column. So that was hugely successful because we wanted to get the spacing right, make sure it met the certification of the bollards, and also it was right on our terminal storefront. So how are we going to make sure this looks good? And also, we've already have the model, so let's use it instead of them just drawing some 2D pictures. We also did the underground services as well, where we had 2D, and when you have underground sanitary and storm, you've got your invert, so we use that to make sure that the foundations and all the pipework didn't interfere. So that was a successful project that's still in the works at the airport right now. The one that we're also started 3 years ago in the middle of right now is passenger experience upgrades with our public washrooms. Basically, they're $1 million a pop, plus or minus. So, and the only thing you can see, touch and feel at the end of the day is the terrazzo and the tile. And so we wanted to get that dimensionally accurate because all of the other functions that go with those washrooms, basically occupancy sensors for lights, for airflow, all of these things that are built in that no one sees, had to be built right, cost effectively, but we also had to make sure that it was dimensionally accurate, because if you don't put the wall in the right place, then the tile dimensions all don't work. So for these projects, the latest design team is TA Scott & Associates, and the latest constructors that have got it is PCL. So this is a 350 LOD. So basically each tile is an asset, so they actually bring the tile in. So with 18 mil spacing, the Schluter strip corner guard, the grout, it's all, the interference is all done on the drawings. So when they go to build it, we only had some minor deficiencies where they just didn't put the backer grout on the right. So they had to strip a couple corners out. On our first set of washrooms where we didn't design in 3D and actually have the higher level of development, They stripped out 40% of the tile and redid all the corner guards, did terrazzo extras because of we wouldn't accept anything on the finishes that was deficient. So by going to a higher level development, all that finish detail got resolved on the drawings, so that the constructors, we didn't scan as we built, but we measured as we went to make sure everything was in the right location. So it finished ahead of schedule. The contractor made money. The first guy didn't, but the previous set of contractors are being efficient in their work. So there's a few other examples here. This isn't the picture of it finished. This is the model with it rendered. Here's another set of washrooms, gate 14, looking down in. Not a lot of detail here, but this is from the model looking at the finished product. And I've got another project, didn't bring the slides, but they're true to life. The terrazzo's off, but everything else is accurate visually and also dimensionally, which is key. Another project we're doing in Revit now is office renovations. The TA Scott has these as well. This is our operations on our floor. This was all done in Revit 350. This little section's complete, so is this. That's actually from the model, not a photograph. And what really went well is because, again, everything was resolved in advance. This was built in the basement area of the building, so there wasn't a lot of conflicts with surrounding equipment. This is relatively free of mechanical, electrical systems. It bordered on a LAN room, but this is for the IT department, so we got that fixed before we built, so they avoided their own issues. So again, we're on multiple fronts with different projects right now. So we started as a pilot project, and then all our designs, all terminal expansion is 3D right now, Revit. And I'll go into moving into the construction environment using BIM, but we have another project doing that, but none of these other ones currently have a contracted mandate that the contractors have to follow the BIM building process like we've just seen in the previous presentation. So this one is passenger experience upgrades. We have international rivals, center core, and pedestrian bridge, and this is the lighting upgrade. So again, we had it modeled in advance, and a few projects before this, we actually have, if you know, architectural design drawings, or even the Revit model needs to be screwed to the earth. So by doing this, they're able to use the position on the earth to actually see where the sun comes up and sets in different times of the year, so that we can daylight harvest in the model instead of actually, just doing your lumen readings and tweaking it afterwards. So in advance, we designed the system so that we would get that out of it, and then did lighting selection, did a pilot, just did a concept check to make sure we thought we would get, put the lighting controls in. So that's one area. So that's their center core area with the food court on the right. And then this area is international rivals. So again, daylight harvesting. So this project is replacing all the high lighting, which is usually expensive. So we switched everything to LOD and modeled the structure, modeled the lighting benefits out of it in advance. It takes longer, but when you go to do it, you get what you're looking for. Here's a model of that looks like a photograph except for the concrete, but that's our ped bridge going over the parking garage. So our project managers are keenly interested in using this. It's cool, but you can actually see the benefits in the field. Passenger experience upgrades. So 2 and more projects and they're small. All of these ones. Nothing's $3 billion. We're talking 50 million to 20 million. But again, getting it right the first time helps. So there's 2 areas working on. One's opening in 2 weeks, the other one's just a concept. So this is nursing mothers, it's the Revit model, and one's a photograph. You pick which one's real. So that'll open in a couple of weeks. We're just waiting for the signage outside. So by getting this all right, the millwork was all done in the shop. It got put up, nice and simple. What I do like about the thing is the contractor's making money. Instead of us rejecting the work and they have to redo it, and then next time the price is higher. and you can see where that's going. So by doing this, what we want our contractors to make money, not too much, but we want to make sure that we get the job done right. It's designed well. The contractors come, build, and leave, and they're happy that they got the job at the airport, because it's hard to work at the airport. You have security. It's an operating building. It's an old building. So here's another area. This is just an idea of a restaurant that's closed. If you're familiar with the terminal, that's Beaches. It closed a couple weeks ago. Another project that I'll bring up in a second ago is going to demolish the kids' play area. So we just want to concept a location to go into the old Beaches and tear out the bar and put the kids in there. And if you're familiar with the area, that's the place to sit and to watch passengers go by, where people drink beer. Well, the parents will guard their kids behind them, hopefully. So again, not even started, not even contracted, no design drawings, just model it to get internal approval on the project before we go forward. Other thing that we're using, since we've got this model and it's enriched in different areas, we've got some maintenance problems. We've got some leaking interface between a curtain wall and a roof. So again, this is just the rough model with the scan on the outside. So we had that developed a little in more detail, so that we've got this, where the wall meets the ceiling. We've got some leaks at the bottom of the windows. So since we already have the model, let's enrich it and find a detail. We did a couple little openings to see what we have in there. We got it dimensioned so that we can contract it and know what we're going to build. So we're going to fix this problem in a few weeks. This is just a small use of the tool that we're progressively building. So now we'll get to passenger processing terminal expansion. This project overview is for two reasons. First is CATSA screening requirements are constantly upgrading. Our passengers, we just hit over 4 million last year. That's a new threshold for us. And the federal government's also constrained on staffing, so capital money is used so that the equipment will process people faster with the same number of people. So we've got a footprint, I'll show you for that. Also, because of the ground floor footprint, we've got hold room expansion. And if you're familiar with the terminal, it's congested in the north where the sun flights leave. Also, Air Canada flies Toronto, Montreal out of that end, and all the stores want to be there. So it's a bit of you got to run the gauntlet just to get through that area. So that's also part of the process. And it'll also build extra space for future master planning projects that'll come in the next 5 years. So here is the concept that we started off with. Before we ever started the project, on this yellow area and gold area is the ground floor of the terminal. The red line is the existing apron terminal interface. So this is the first floor, so we want to build out onto the apron. And on the second floor, consolidate the concessions so that we can move the high-volume, high-frequency passengers to the middle and consolidate the concessions there so that they can spend money and reduce increase our non-aeronautical revenue so that we can have the airlines here cheaper and make the operating budget out of the passengers using the facility. So it's a win-win for passenger volumes and for the customer experience. So the gray area is the roof, and we have some fire exiting requirements to get there. And because we had an option to do a 2-story or a 3-story through the modeling process that WSP did for us during the project, and the budgeting that they did before we ever tendered, we were getting close to, well, what can we build here? So we found out that we wanted to do the 3rd floor, and we found the money to do it, and so we progressed with the 3-story. So this is the model rendering from the apron looking back at the expanded terminal with a new brand and on one of the new stairwells. So this is what we're in the ground building right now. Foundations are in, the fuel line's been removed, utilities are installed. Demos just about done. Structural steel, I seen the crane yesterday. So we're starting the builds. We've got aprons closed. gates closed during phasing, and we're on schedule and we're on budget. And that's vastly because of the advanced Revit modeling that we did in advance, and then follow that construction process. We're still finding small issues, and I'll get to that in a second on lessons learned. But the schedule, you're never on schedule at the airport. And because of operations, we had to be on schedule because we need all our gates in the summertime, and we took 2 gates out at a time before Christmas, got our gates back operational at Christmas. Then we took 2 until Sunflight season. Sunflight season just finished, and so we got our gates again 2 weeks ago, and we have to have the steel up for July 2nd weekend. We lost 3 days, but we had a week of float, and we've got a plan to get it back. So having all that done in advance really helped. So one of the things that we used, we had scans from our model, the original model. WSP came in and scanned. So one of the lessons we learned from the WestJet infill project was that we didn't scan around the area. So that those change orders we had on the foundations and the structural tie-in to the existing building, we had a similar experience with a parallel project that I didn't put on the slide deck. So this time the Revit model was contracted to include a bay surrounding the footprint. So we also scanned a bay surrounding the footprint so that those interface tie-ins would be known so that we would avoid those change orders on site. So I'll go through some more of the, I don't have a lot of detailed Revit drawings here. I've just got some of the 3D drawings showing the views afterwards. This is our PreBoard Screening expanded. This is our new 40% deeper check-in hall for the longer CATSA Plus screening lanes. If you guys experienced in Toronto, Montreal's got theirs, Calgary, and Vancouver. So this is designed for that same equipment. This is the 2-story hold room. This is that commercial infill, this bump out that we've done. So this area right now is on the apron. If you're sitting in this area, it's not built yet. And that wall you see on the right, that is the existing edge of the building. In advance, all the materials are chosen. We have a 3D model for management approval. That can be done without Revit. There's other programs, but all that layered on truly has a benefit for management approval and also the other benefits that I've already mentioned. This is top of PreBoard Screening. If you guys fly out of Toronto, any visitors here or anyone that comes and goes for business, you know at the top of PreBoard Screening there's the credit card lady, and then there's the FIDs, and everybody stops, and the traffic is, it's a standstill as soon as people get stopped. So there'll be a bay in front of that opened, and then the expansion is 1 bay past. So you'll freely flow into the hold room. We've got a central information hub here where people can stop, edit the traffic flow, look at where they want to go. The tablet on the bottom or the screen on the bottom shows some of the other facilities that they can visit for restaurants and shops instead of the tenants wanting to put signs everywhere so that people can find them with pop-up signs. So moving to a technology-based system so that people can find those other services. And we haven't even started any of the expansion yet, and 60% of our commercial locations are already booked. So we have the Firkin Group out of Toronto has a connected coffee install. They've got the Firkin Flyer Pub that's going to start construction before we have the expansion done. This will be open before we have the new footprint, so we're straightening out corridors. This is an adjacent space that was made available, and this also got opened a couple weeks ago, and this store also opened just off the footprint. So that scan of a 1 bay all around really helped with our program. So what's next for us? This is the last slide, but I want to talk about some of the things that we've learned through our process. When we first started our level of development, we didn't even know what that was. So for us, we put in our contract documents conflict resolution. Many times during a 2D design, you get the mechanical or the electrical guy to do the conflict drawings, and that'll help with a lot of the issues. So we wanted it to design for in enough detail so that the designers would have everything drawn so that we didn't rely on the trades, because death by 1,000 knives is usually what we have during a project build, because the first trade that got there decided the datum point for everyone else. And I think they all had 8-foot ladders. So if you look above our ceilings, there's 2 feet of infrastructure and then 4 feet of nothing. So when somebody loses an inch, our ceilings have to drop. And there's no contractual way to hold anybody to it. But by having the 3D model done to that level of development, we maximize all our ceiling space, put everything up high, and then our goal was and still is to tell the contractors where to put things, check to see that it's there so that the next guy has his space that was already identified to him. So our level of development has increased since we first started. Instead of just saying conflict resolution, we went to 250. We didn't get what we thought we needed. We still had some change orders. We went to 350. And the PPT, or Pasture Processing Terminal Expansion, has a 350 design requirement and a 400 as-built. And again, this is our pilot project to build with BIM tools. So Lindsay's Construction got the contract, and we're using tablets in the field, BIM 360, BIM Field, BIM Docs, so that we can actually take the design into the field. Because what we're used to is the roll of drawings, the job meeting. Drawings are rolled out, and each guy puts his things there. You got the taped change orders and change directions right on the drawings, and it looks like by the end of the job it's a roll of rags. And that's a historical way that things have been built everywhere. And we were inspired during the IKEA build when we had Bird building the WestJet space. They had a screen up on the wall for construction, building the IKEA building here in Dartmouth. That really they fixed problems with the trades in the building. So this is our pilot project of that process, to actually use the trades to implement the tools to make sure that they have a place to build. They can build efficiently in the right location, and give the tools to the trades to do that. So some of the experience we've been having is we've got our international firms that are in Canada that design here in Halifax with local offices, and also we have national contractors that have BIM specialists. But here in Halifax, we don't have that same expertise locally across all of the contractors or the designs. And when it really gets down to it, you need the people that have the expertise and the processes behind them. So that has been one of the things that we want to help develop here in Halifax as an owner, so that it builds industry and we can continue on our journey to continue to save money and make things easier to build and stay on budget, on schedule. And the other goal we have is facilities management, to pass on this information into our Maximo product so that the building can be maintained with warranties and all the information about the built condition of the terminal. So I think that's my 20.